So lesson 2.5 is completing the square. Okay, that's going to be our big name of the game of how do we solve an equation using completing the square. And I'm going to tell you up front, it's not our go-to method. It's not our method of, okay, I can't factor, I'm going to complete the square. Okay, because keep in mind, probably the number one way you're going to solve an equation, a quadratic equation, is by factoring. That's going to be the number one method that we usually check. But factoring doesn't always work. Not everything is factorable. So we have to have backup plans. Now, completing the square is technically one of those plans. To me, though, completing the square is one we use in specific situations. Okay? When we talk about quadratic formula, that's like the no-fail backup method. Now, before we actually talk about the steps to completing the square, we're going to go over how we can kind of extend on yesterday of how we can use square roots to solve quadratic functions. Okay, and we've got two different things happening here that we're going to talk about. And again, just trying to set you up for when we complete the square here shortly. So with A, 4x squared plus 10 equals 46. Think about how we ended things yesterday. How do you think you're going to solve for x here? Okay, subtract the 10 over. In an effort to work to get x squared by itself, right? And we can do this because in this particular problem, there's only an x squared term. And this works when there's only an x squared term. So, yes, let's subtract the 10 over. So that's going to leave me with 4x squared. 10's cancel. 46 minus 10 is 36. Based on what we talked about yesterday, what's the next step I'm going to recommend? Divide by 4, right? Get that x squared by itself. So divide by 4. So then I have x squared equals 36 divided by 4 is 9. And final step? Square root, right? If you can get it to x squared equals a number, your next step is to take the square root of both sides. Now, the key is, can you get this right? Okay, the square root of x squared is x. What about this right-hand side? Square root of 9?
3.
3? Do we need to say plus or minus? We do. Okay? And you will hear me say often throughout this school year, in an equation setting, when you take the square root, we have to consider both the positive and negative solutions. Okay? If you just have a random problem that says, okay, what is the square root of 9? I agree. The square root of 9 is just 3. If they wanted to say what is the negative of square root of 9, then they'd say negative 3. Here they'd say 3. If they wanted plus or minus, they'd put that sign out front. Okay? Now, with that all said, they didn't give us the square root sign, did they? We put that in. And when you put that in, you have to remember, okay, we have to consider positive and negative. Could positive 3 and negative 3 work in this equation? Yeah. Okay, it could. So you need two solutions. Get used to it, guys. Most of the time when solving a quadratic equation, an equation that is x to the second power traditionally has two solutions. Okay, so always look for those two solutions. I can't say always, but traditionally. Okay, so that's continues where we left off yesterday. We just didn't have an I, right? No I's today. You learned about I's, but we're not using I's in this lesson. We'll talk about them more with quadratic formula. Now, on B, x plus 7 quantity squared equals negative 25. Well, I just lied. I forgot. I guess there are a few I's in this lesson. Dang it, I forgot. Okay. Now, if I ask you guys what we're going to do, well, let me ask. There's two directions we could go with this. But there's only one direction I'm going to take you because I want to check out a specific method here. If you guys are sitting there looking at it, what are you thinking?
Distribute the square.
Okay, and distributing the square in this scenario you don't exactly just distribute it, you'd have to x plus 7 times x plus 7, which means you'd have to FOIL. Could we FOIL this out? We could. Okay, we're not going to. Okay, I have a different direction I'm going with this. And again, keep in mind, this is all preps for when we get down to the bottom. How do we complete the square? Okay, yes, we could FOIL this. You could make your equation equal to 0. Although in all reality, it wouldn't factor. So then you'd be stuck again. Now, on that left side, x plus 7 quantity squared. Is that a perfect square like x squared? Is it something times itself? It is. So because I have parentheses squared there, we're going to jump straight to our square root step. So look at how this works. Okay, x plus 7 quantity squared. Well, because it's something squared, I'm going to jump right in and say, let's take the square root. Now, you know the drill. What you do to the left, we do to the right. So I'm taking the square root of the right. Now, take a guess on the left. X plus 7 quantity squared, the square root of that. What do you think we're going to get? What are the square root and this squared going to do to each other? They're going to cancel each other out, right? They're inverse operations. A square root and a square are going to cancel each other out. What's that leave me with? X plus 7. Okay. On the right, what do I need to say on the right? I mean, we can talk about what the square root of negative 25 here is in a moment, but what do we need to not forget to put on here? What do we need to not forget? I'll do the square root of negative 25 in a moment. What needs to go here? Plus or minus. Okay, because again, did I take the square root in an equation setting? I did. Okay, so I took the square root in an equation setting, plus or minus. Now, let's clean up that right side. And you may have already done that. Awesome. Plus or minus, what is the square root of negative 25? Can we do that without putting steps down, or do we need steps? Square root of negative 25? Square root of 25 is 5. The square root of a negative makes it 5i. So this is going to be plus or minus 5i. Because remember, we broke it into square root of negative 1 times square root of 25, which is I times 5, or 5i, right? Okay. What do I do to finish solving for x? If it's x plus 7, you want to move the plus 7 over, so we're going to subtract 7. Now, on the left you have x. On the right, technically, I don't think there's a right versus wrong way to write it. But I'm going to go with there's a preferred way. And that, I mean, could you write plus or minus 5i minus 7? You could, but it's awkward. I like to, anytime I have a plus or minus sign, I like to put it in the middle. But that also fits the form of a plus bi form. So I'm going to write this as negative 7 plus or minus 5i. Can I go any farther? No, because 7 and 5i aren't like terms. So your answer is x equals negative 7 plus or minus 5i. How many answers do I have there? How many answers does that represent? 2? Because one answer is negative 7 plus 5i, whatever that is. And the other answer is negative 7 minus 5i. Okay, just like over here, we had 2 answers, positive 3 and negative 3. Okay. Are we okay with that? Okay. Now, C. Could we set our equation equal to 0 and factor? Yes, we could, because this one does not have imaginary solutions. However, that's not what I need you to do, because we're trying to set ourselves up for something called completing the square, which technically you saw in Algebra 1. It was introduced in Algebra 1. You probably, I can guarantee you don't remember it, though. As it is right there, that left side, you don't necessarily realize it right now, but that left side is a perfect square. Okay? Now, in terms of seeing it as a perfect square, take this left side and factor it with me. Don't move the 81. We're doing this because this left side is a perfect square. I just have to prove it to you. So go back to basic factoring skills from the beginning of the chapter. X squared breaks into what? X and X. The numbers that go in the back of the parentheses have to multiply to be 36 and add to be 12. Well, folks, what's the square root of 36? 6. So 6 times 6 is 36, and what's 6 plus 6? 12. If it multiplies to be positive and adds to be positive, this is x plus 6. Now, I wrote it out that way because I felt like I needed to, as we're just starting this, right? But how can x plus 6 times x plus 6 also be written? This is the same thing as saying x plus 6 quantity squared equals 81. Okay? Now do you see why I did that? Again, I'm trying to set us up for x plus 6 quantity squared. It's a perfect square. We can take the square root. Okay, so square root of both sides. It's going to work out similar to the last one. The square root of x plus 6 squared. X plus 6, right? The square and the square root, they essentially cancel each other out. Probably not the terminology I should use, but it makes sense to you guys. What about that right side? We're taking the square root of 81. What are we going to get? Okay, square root of 81 is 9. We're in an equation setting, so I'm going to say plus or minus 9. Okay. What do we do to finish solving here? Okay, if it's x plus 6, we're going to subtract 6. For the meantime, I can write this as negative 6 plus or minus 9. But if you stop there, I'm counting you wrong and Sabas is counting you wrong. Why are we counting you wrong? Is that math we can do? Can we add negative 6 and 9 and subtract negative 6 and 9? Yeah, that's math we could do. Could we do the math on this last problem? No. So on this last problem, because it was the 5i involved, we couldn't go any farther, so we stopped there on purpose. This one, you can go farther. You can do what is negative 6 plus 9 and what is negative 6 minus 9, right? You can do that math. So, I guess I'll put my answer over here since I'm running out of room. Negative 6 plus 9 is 3. Negative 6 minus 9 is negative 15. Okay? And again, if you look at that and say, man, I could have just made that equation equal 0 and I could have factored that so much quicker. I'm not arguing that fact. But I'm trying to get a process into you that we can use when completing the square. Okay? Just given this problem on its own, is that how we would necessarily do it? Depends on who you are. Okay? Okay, one more. Can you take a guess? I'm going to tell you, no, we're not going to make this equal to 0 and factor. Can you notice anything about this left side? Yeah, is this possibly going to be a perfect square? Okay, it is. Because can I take the square root of 64? It's 8. And does 8 plus 8 add to be my middle term? It does. Okay. So, let's factor. So I'm keeping my equal 7. X squared breaks into x times x. Multiplying to be 64, more specifically the square root of 64 is 8 times 8. How do I get those 8s to multiply to be positive 64 and add to be negative 16? They're both negative. Or in other words, this is the same idea as saying x minus 8 squared equals 7. And now, because that left side is a perfect square, because it's x minus 8 quantity squared, we are set to take the square root. What I do on the left, I do on the right. On the left, what's the square root of x minus 8 squared? X minus 8. On the right, what's the square root of 7? Plus or minus the square root of 7. Do I want decimals again? No, I still don't want decimals. We're still sticking with the square root sign. Don't forget, you got to put the plus or minus in there. Good. Okay. And in order to solve for x, how do I get x by itself? Yeah, if it's x minus 8, we're going to add 8 over here. Now, we don't have any i's to worry about position, but I still stand by, not required, but I feel like the best form, a plus or minus to me makes more sense if you put it in the middle. Could I write my answer as plus or minus the square root of 7 plus 8? You can, but I would rather put the plus 8 out front and say 8 plus or minus square root of 7. And any math teacher is going to tell you the same thing. Okay, I don't know, some might even say you have to. I don't know that I would technically argue that you have to, but it's definitely more commonly expected. How's that? Okay, you got the basics down. Because here's the deal. We're going to kind of add to this, okay? This is, we're using square roots here. So this is a build up from where we left off yesterday. But now what we're going to do is we're going to take equations that aren't necessarily perfect squares, and we're going to, quote, complete the square. So we're going to create perfect squares so that we can do this method here, okay? And that's where we are headed next. Now, you will notice I have my attempt at writing out a list of steps for completing the square. It's a process. Now, what color is our formula paper? Is it blue right now? One of the things on that blue formula paper, and I said, don't stress that. You're like, wait, we haven't talked about this. This is something that's on there, is these steps. So I'm nice. I'm going to give you the steps. The steps don't do anything for you if you don't understand how to use them, though. Fair enough? They only help you if you understand what they mean and how to use them. So, okay. And I will say, these two examples right here, you can try all you want, but they're not going to factor. Okay? Doesn't matter. You can say, oh, I'll slip and slide, I'll divide. These don't factor. Okay? So, we need a different method. Factoring fails us here. So, step 1 up there. Rewrite the equation in the form x squared plus bx equals c. So, and I'm just going to go through step by step. So on A, we have 3x squared minus 12x plus 6 equals 0. We need this to be in the form x squared plus bx equals c. So there's two things to notice about that form. First of all, it's not equal to 0, is it? It's equal to c, which means your constant needs to move over. The other thing, did you catch the other thing? What's in front of x squared? Nothing. So what's the only number allowed in front of x squared? 1. Does that look like a 1, or is that getting kind of... I was trying to make it look like a 1, and I don't know what I made it look like, but... Okay, so those are the two things that have to happen. My equation is not equal to 0. We move a number, a constant, over, and there is no a value. So we'll have to divide that out. So what steps do I need to take on my example here to make this happen? Okay, so, and technically on this one you could do this in any order. If you've got like terms and stuff to put together, I'd always do that before you divide anything. But let's go ahead and subtract the 6 over. When we subtract the 6 over, I now am at 3x squared minus 12x. 6 minus 6 is going to cancel. Now, I'm going to go ahead and start doing it now just to get in the habit, but because I know what's up and coming, I tend to leave a little gap after that bx term. You don't have to yet, but here in another step or so, you will want a gap. Okay? And then on the right, 0 minus 6 is negative 6. The other thing that needs to happen. Right now, I have ax squared plus bx equals c. I need it to not be ax squared. I need it to be 1x squared. So we also need to divide by this a value of 3. If you divide that first term by 3, every term is divided by 3. So that puts us at 3x squared divided by 3 is x squared minus 12x divided by 3 is 4x. I am definitely leaving a gap there. Hint, 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 hint. And then negative 6 divided by 3 is negative 2. Okay. That's step 1, folks. Step 1, rewrite the equation in this form. We did that. I have x squared plus bx equals a c value. Okay. Step 2. This is the step. Okay. Complete the square by adding b over 2 squared to each side of the equation. So what we need to figure out right here, b over 2 squared to each side of the equation. Tell me, what is my current b value? Current b value is negative 4, yes? And I say current, I don't care what b started off as. Okay, I care what it is right now that we're at x squared plus bx equals c. So b is negative 4. Well, we're supposed to do b over 2 quantity squared. So if I'm doing b divided by 2 quantity squared, that means what are we going to do? Negative 4 divided by 2 quantity squared. What is negative 4 divided by 2? Negative 2. What is negative 2 when you square it? Negative 2 times negative 2 is positive 4, yes? Okay. That value right there is what we're going to use. Dang it, I got a little too close there. Crud. Okay. Now, what do we do with this? We complete the square by adding b over 2 squared to each side of the equation. I left a hole, right? I left a gap on purpose. We're going to take this 4, and we're going to add 4 on the left side. We're also going to add 4 on the right side. Hold on, I'm going to scoop my There's an equals -2 there, right? And then we are adding 4. Sorry. Okay. So that's step 2 right there. I figured out what b over 2 quantity squared is, and I'm going to add it on both sides of the equation. Are we okay with that? That is the step. That is the important step in all of this. Okay? Now, step 3. Factor the left side of the equation. Folks, this is what I was preparing you for in the last part. Factor the left side. Well, I'll go ahead and set it up like that, but there's going to be something special happen every time. X squared breaks into what? X and X. What multiplies to be 4 and adds to be -4? Yeah, -2 and -2. Or, let me shortcut it. What's the square root of 4? 2. Okay, that's always going to be a perfect square that you can then break up. Since it adds to be -4, it's -2 -2. Or in other words, x minus 2 times x minus 2 is x minus 2 quantity squared. We'll always clean up to parentheses squared on that left-hand side, if done correctly. How's that? I say always, but assuming it's done correctly. Now, on the right, just carry the right down, or I'm going to kind of clean up as right here. What is -2 plus 4? That is 2. So I'm just cleaning that up, and I'm carrying that down. So step 3, we factor the left side. That left side will always go into parentheses squared. Okay, step 4, square root both sides of the equation. You know what to do here? We've already done this today, haven't we? This is up top when you're like, ugh, I don't like, why are we solving it like this? Here's why. So square root both sides. So square root. On the left, what's the square root of x minus 2 squared? X minus 2. On the right, what's the square root of 2? There we go. Plus or minus square root of 2. I wasn't arguing square root of 2, but I need you to remember to write that plus or minus down, right? Okay, we square root both sides of the equation. Step 5, finish it off. It says solve for x. Finish it off. If it's x minus 2, what are we going to do? We're going to add 2. So minus 2 plus 2 cancels. I have plus or minus the square root of 2 plus 2. I personally am going to write this as 2 plus or minus the square root of 2. And there's my proof, folks. I could not have factored this when I get an answer like this. It can't happen. Okay? Questions? Obviously, that was, kind of a basic example there. There's steps to it. If you can figure out the process, it's doable. Okay, where am I at on time? Can we get through B? I think we can get through B. And I'll save a couple more for practice tomorrow. Let's do it. Okay, step 1, starting all over. Rewrite the equation in the form x squared plus bx equals c. What do I have to do to put this in the form x squared plus bx equals c? Okay, I need x squared and x on the left, number on the right. So the 3 has to go. So we subtracted it. So now I have x squared minus 2x. I'm going to go ahead and start leaving my gap. And 0 minus 3 is negative 3. Anything else for step 1? It's 1x squared plus bx, right? I already have 1x squared in this case, don't I? So I don't have to divide by anything. Okay? So, step 1. Check it off your list. Step 2. Complete the square by adding b over 2 squared to each side of the equation. Okay. What is my current b? X squared plus bx, right? So b is negative 2. And put it into that little formula of b over 2 quantity squared. So negative 2 divided by 2 quantity squared. That's a lot of 2's. Negative 2 divided by 2 is negative 1. Negative 1, when you square it, is 1. Okay. So now, what do I do with this 1? Complete the square by adding b over 2 squared to each side of the equation. So, plus 1, plus 1. Okay? You see why I'm leaving the gap, right? Not that you couldn't erase, not that you couldn't just write another line, but that's why I start leaving a gap. Okay? Step 2, check it off your list. Step 3, factor the left side of the equation. Depending on your level of skill, you could go ahead and set it up as it's going to become something like that every time. Okay? So you know it's going to be 2 identical parentheses. Now, if that's a little much for you and you're like, that confuses me, then what? Go back and just think like normal. It's parenthesis times parenthesis. Okay, you do you. X squared is x times x. Or what's the square root of x squared? It's x. 1. I need numbers that multiply to be 1 and add to be negative 2. Or what's the square root of 1? 1. What kind of signs do I need here? Negative. Anytime that middle term is negative, in this scenario, you're going to need 2 negatives. So this is x minus 1 quantity squared. I will tell you also, I don't know if you guys have caught this or not, over here, it was x minus 2, right? It's also this number here in this step before you square it. There's a connection there also. Okay? Let's see. Did you clean up the right as you went? I didn't. Negative 3 plus 1 is negative 2. So I have the equation x minus 1 squared equals negative 2. What are we going to do? Square root. I guess technically we're ready for step 4, aren't we? Sorry, in my brain at this point I just start solving. I forget the steps. 3 was factor. 4 is square root. Hopefully you'll get to the point too where you don't really need the steps as much. But square root of x minus 1 squared is x minus 1. A square root and a square, inverse operations. They cancel each other. On the right, square root of negative 2. I got the plus or minus. So you start off with square root of negative 2. But, okay, so can I take the square root of 2? No, that's going to stay square root of 2. But there's a negative. What do we know the negative is going to become? That becomes the I, right? So I'm going to rewrite this. The square root of the negative is going to become I out front, and then 2 stays under the radical. Okay? Write that into your steps if you need to. And I square rooted both sides. Now we're going to solve for x. If it's x minus 1, I'm going to add 1. X equals, when we add 1, it's going to be what? 1 plus or minus I square root of 2. Again, I keep putting that plus or minus in the middle. Whether it's an I or not, I'm putting that plus or minus in the middle. Okay. We're not getting through another one in 2 minutes. So tomorrow, we'll work on the backside notes. We have 2 more of this process to practice. And then we're also going to look at how we can use this process to rewrite an equation that needs graphed in a better form. So how we can write it in vertex form. Okay? Okay. Lesson 2.5 will be available in Savas. It won't be due till next week. And it is not on this 9 weeks. Doesn't mean you shouldn't do it in a timely fashion, but just FYI there. Okay?